Okay, hello guys. So here in this video, we're gonna give the definition of a group. So you can start solving your homework. Definition. Definition of group. So a binary operation on a set G. You have a set G, okay? So, and you're gonna define a binary operation on the set G. So G could be the integers. It's a function so let's make this little circle for the operation. That is gonna get G cross G and send it to G. So basically it gets an A and a B and send it to A operation B. So it could be adding, subtracting, multiplication. But if you have matrices, it will be matrices multiplication. Okay. So when you define a group, you need also to define the operation you're using in the group. Okay. So we first establish what is a binary operation. And this A composition B must belong to G. So if your operation doesn't lie in G, well, it's not operation. Okay. So with this operation, we define a group. A group G with this special, this means operation, no? This little circle is a set G together with a law of composition AB is assigned A compose B that satisfies the following actions. So the first action, so but notice that it's hidden that this must be true. So that's something that to show that it's a group, that's the first property you need to show. So don't forget that, okay? So the next one is the law of composition is associative. That is A composition B, composition C equals A composition B, composition C. Okay. So it's associativity. So basically we want to extend the properties of the integers. So the favorite group is, so this is your favorite group, right? Okay. But we're going to extend it to symmetries of a triangle, symmetries and reflections of a triangle, symmetries and reflections of a rectangle. We're going to extend it to matrices. We're going to extend it to something called quaternions. That is are kind of complex numbers in 4 dimension and things like that. Okay. So number two, there exists there exists an element E in G called the identity element, such that for any element A belongs to G, you have E composition A equals A composition E, and it gives me the same A. And the last property, so you see, this is really minimum to ask. It's like, that's the idea, like, if you have a set, what is the minimum mathematical structure you can provide to that set? Okay. So real analysis, you require too much. You require the real line has so many properties. Remember, we got like 10 properties. This is just a set with 3 properties. 4 basically. For each element, A belongs to G. There exists an inverse element in G denoted by A inverse, such that A compose A inverse equals A inverse compose A equals E. That's the most difficult property to get, to have inverse, okay? So that's really the property. If you want to see that something is a group, probably that's the first property you need to check. Because it's the hardest to get. So let's call it a remark. If a group G has the property that A compose B equals B compose A for all A and B and G, then we say G is an abelian group. So, or let's put it like furthermore, like not remark, furthermore. So you use all these. So it has to satisfy 1, 2, 3, 4. Furthermore, if a group G has also, let's say, also the property that is commutative, then we say G is an abelian group. If not, it's a non-abelian group. Okay. Okay. So with this, you already have homework. So I'm gonna record the first video this week and giving you examples of groups. Okay. So you can start with your homework. I'm gonna finish this video so I can upload it.